Well, it's John Black again. I wanted to, before I went into the thought experiment, the tunnel thought experiment by Albert Einstein, I wanted to, because it's about being simultaneous. Um, I wanted to go back and review on the Minkowski diagram. And remember, this is the spaceship guy, the guy leaving Earth and then coming back. As he goes away from Earth, as you can see, these, from Earth, A and B are simultaneous, okay? But as he moves away from Earth, his simultaneous lines move more and more to this type of angle, where B actually happens before A. And you could say that light travels faster, so B obviously is going to, because B gets there first, it's closer, the light gets to you first. But think about this now, when you come back to Earth, okay, this A happens before B. How does A happen before B? This light is, from position B is closer to you than A. Okay, so it can't be about the speed of light. You know what I mean? I mean, it is, everything's about everything a little bit. But what I'm saying is you can't just attribute it to, oh, well, this B point is closer to this guy than A is. So obviously the light gets to him first with B. But what about over here? B is still closer. Look at that. B is still closer. Why does A happen first? That's what simultaneous is about each frame of reference. Nothing is, you can't say simultaneous is universal across the whole universe. Every person from every different frame of reference will have a different say-so on it. I'd like to reiterate, I cannot stress this enough because it will go into play on my one video about the dimensions. Um, when you are moving, see this guy, remember the spaceship, he's moving. His now is not the same now as you on Earth, because this is now for you on Earth, and he gets to the planet at this time. That's now. But for him, now is your 3 years ago, or your 2 years ago, number three. And that is, and remember, every frame of reference is equally valid. That means it's just as true as what you say. Now I want you to look at this arrow here, okay? And I'm not going to go from the past because, like I said, this kind of, it looks like B you should see first anyway because B is closer. But when you're moving forward towards something, it does the opposite. So I'm going to concentrate on that. When he comes back to Earth, here's B. It's closer to him than A is. The light should hit his eyes before the light from here hits his eyes. But he sees A happen before B. How is that even possible? Okay. Isn't that weird? Isn't that freaky? Anyways, the reason why is because clocks differ in not only frame of reference, but on distance. So far, everything I've been talking about has just been time. Now we're going to get into distance, okay? B explodes and A explodes at the same time. But since you're moving this way, your direction is that way. And I want you to see how the clocks, and this goes for over here too. You just change this arrow, instead of it pointing that way, you would point it this way. And the clocks would be faster here and slower here. Everything, and it's not just they're faster in front and slower in back, they're more faster. Like at this point, it has a faster clock than you, okay? But more ahead of you, it's even faster than both of those clocks. And the clock ahead of that is faster than the clocks, all three of those clocks. And the clock ahead of that is even, and that goes on forever and ever and ever. And the same with behind you. Behind you, this clock is going a little bit slower, but this clock behind both ends is going even slower. The clock behind all three of those is going even slower than those, and so on and so on and so on throughout the entire universe, I'm suspecting. So you need to keep that in mind. And here's a little example. These two X's are explosions. They're on Earth. This guy is on Earth. Everything is on Earth. These are all in the same frame of reference. he sees them blow up at the same exact time. This guy right here, he's coming towards the explosions. He should see this one first because speed of light, obviously. He'd see this first before that. But he sees this explode first before this. I mean, that implies that present and past aren't, you know what I mean? That they're not set. I can't explain it right now. I'm just going to screw it up. I'll save that for the other video about dimensions. But you can see that what happened in the past doesn't necessarily mean it happened in the past. Someone else's simultaneous lines, it could have happened beforehand. Because how else could he see this explode before the closer one explodes? It's because this already happened. Everything already happened. The future happened already. The past happened. It's already happened in a static, non-moving universe. But I'll get to that later. Like I said, he comes by. This guy sees him explode at the same exact time. This guy, no. He sees this one explode first, then this one. Now, let's move on to this next picture here. As you can see with the next picture, I got 3 different pictures. The first one is black, right? The black truck or train, whatever, as long as it's a long vehicle, is driving through this tunnel. This is at regular speed on a highway, 60 mile an hour. This is the size of the tunnel. You can obviously see that tunnel is smaller than the truck, right? It cannot fit inside the train. That's a fact. Now, let's say the train is moving or the truck is moving at the speed of light, or 90% speed of light. From the truck's frame of reference, he is standing still, and everything else in the universe is moving at almost the speed of light. So you standing, this is a guy standing on a planet, watching him drive by. He will appear to this guy, the driver, to look like just a line, basically. The tunnel will contract so that it is small, and the truck driver will say, hey, you know what I mean? That tunnel is smaller. Now, from the Earth's frame of reference, if the guy's standing there watching, he'll see the truck shrink and contract, and the tunnel stay the same because it's in the same frame of reference as the Earth. So he will see it go through the tunnel. Who is right? Well, let's pretend that the tunnel, we install 2 doors that are unbreakable. Nothing can break them. They're unbreakable. And they pop up at the same exact time and pop back down at the same exact time. Okay? So the driver, let's start with the Earth guy. The Earth guy looks at the thingy, right? The truck driver, he sees he's small and he can easily fit in that tunnel. The truck driver drives into the tunnel at the speed of light. Both doors on both ends of the tunnel pop up and pop back down. And the truck driver drives out, and the man on Earth says that all makes sense. Okay. Now, what about the truck driver's frame of reference? He says that the tunnel is too small for him. There's no way he's going to fit in there. But the clocks, remember, according to over at our other thingy here, clocks in front of you move faster. And not just faster, the clocks in front of you all move faster at the same speed. The more in front of you they are, the faster they go. So this clock right here is going to move faster than this clock over here. So according to his frame of reference, the tunnel will contract to be too small, but this side of the tunnel, the clock, is moving faster than this side. So that means that the truck drives into the small tunnel. The door closes on this side, right? The door opens. The train or the truck keeps driving through the tunnel all the way till the back of it is in the tunnel. Then, when the back is in the tunnel but past the doorway, this door closes and then opens real fast. And that's how you get around that. Okay. Um, and so they both meet their criteria. Okay. It's all about simultaneousness. Since he is further on, that's what will happen. Now, let's pretend that we put the doors up and keep them up, right? They can't both be right now, can they? Well, let's go for the frame of reference of the Earth, okay? The guy sees the train is too small. I mean, it's small than the truck is smaller than the tunnel. So the truck drives into the tunnel. Simultaneously, the doors close, and bam, everything works out in his frame of reference, right? But what about the truck driver's frame of reference? It can't work out in his, right? Okay, so from the truck driver's frame of reference, he drives into the train, into the track, into the thingy tunnel. The door closes on this end, okay? Then he shrinks because he's going to slam into that door, okay? And he's going to compress. As he compresses, he gets shoved into the tunnel, and this side of the door can now close. And the train is inside the closed doors of the tunnel. And so it does work out for both ways. Obviously, this guy here, when he slams into the immovable door, he goes in, both doors close, he smashes into this. He will uncondense now because he's starting to move slower. So he will start to expand. But as he expands, he's crunching himself into this door right here. And, so he's going to fit in there. He's just going to be all smashed up. Both situations, doors both close, train gets smashed. Anyways, simultaneous things do not happen the same for everyone else. And that's basically the gist of this video. This is John Black. Hopefully I only have a couple more of these, maybe 2 or 3, I hope, because I can't stand making these. But you all have a good day.